All right. So this is just a demonstration of a uh, DC uh, motor speed controller. Um, so here is a telematics viewer of certain data uh, that are being monitored, such as the actual period. Uh, this is the period of the magnetic encoder on the DC motor. The that keeps track of the speed of which the DC motor is spinning. The It's represented here on the this yellow waveform on the oscilloscope, and the PWM applied to the motor to adjust the speed is represented here. This is the uh, this is the PWM coming from the microcontroller, the 3.3 volt uh, PWM signal. And here is the error error of the actual the difference between the actual frequency and the set point. And the set point is at believe is at 455, and the green is the actual frequency that we're seeing from the microcontroller. So pretty much it's just a this period, this 1 over this period is representing that. Then here is the um, applied PID signal that the PID control loop is applying to the timer, and there is a 8 to 99 or 1/8 1/8 ratio between this signal here and the duty cycle that is applied, which is right here. Uh, and then here it just represents the different profile of the PWM, the duty cycle that are being applied for the PWM, and it mostly ranges from minimum of 9 to 16. I've scaled all of these windows just to have a close-up look of the actual feedback, uh, the actual response, the step response uh, uh, of the control loop. Uh, uh, Ended there. The string ended. Just need to turn that back on here. So let me just turn this string back on. All right. So so I can right now I don't have I haven't implemented kind of a a step response, but we can kind of we can see here. I'm gonna just press the reset button, so it's resetting, and then it steps it. So let's look at here. So we can see here it has a really good step. I've spent some time tuning it and trying to get get it to have a really good response. And yeah, so it's kind of the step response there uh, of the speed controller. Um, go back to the live feed. So it's very responsive. Uh, for right now, there's some sort of there's a delay. Uh, takes a bit of time for it to actually step into the set point that is being set. Um, but that's something that I'm gonna be working on polishing up. Just wanted to show you guys this, and I'm gonna switch here and just kind of show you the actual setup of the motor. All right. So my pen here. So in here, I have my bring this up to frame. In here, I have my STM, my STM uh, STM F4 disco board that is used to control and detect the uh, PWM signal from well, it creates the PWM signal for the driver for the DC motor, and also is using input capture to capture the frequency of the magnetic encoders, which are here. Uh, I have two magnetic encoders, uh, and I originally put two because I was well, yes, I put two because I was using it as an encoder. But really here I'm just using one of them, and I'm using that as a speedometer for the DC motor. So I made a little bit of circuits here. This motor, they came with an original uh, uh, circuit for it for encoding. Uh, I think I was either not understanding how to properly set it up. Uh, it's kind of my first time working with it, so I couldn't get it to properly set up. So I decided to just build my own with a regular uh, prototyping PCB board bought from Amazon, and these encoders are normally pulled high, and and uh, uh, and they pull low upon once I think it's either the north or the south pole of the magnet. It's gets detected. I think it pulls it down. But the magnet is a 8 pole magnet. I got it from Phoenix, America. Uh, they sell different type of uh, 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 magnetic encoder for DC motors. Uh, this is a 2 millimeter magnet. Uh, so uh, so it's kind of my setup here. I have the MOSFET that's driving the motor. Um, well, it can only spin in one direction since I only have a MOSFET. I have it configured as a low side driver with low side driver with the load on the on the drain on the source with the load on the source. So the DC motor there have the suppressing diode there. I am using a BJT back here to actually ramp up, step up that voltage, that 3.3 volt coming from the microcontroller to 5 volt to drive the MOSFET, and then the MOSFET is driving the DC motor. Uh, and ironically, I'm actually powering that MOSFET using this 5 volt using this 5 volt regulator. Oh my gosh. Oh, ground is not connected there. Oh, no wonder why it was so fuzzy. uh, so yeah, ironically, I'm using a motor driver, the 5 volt uh, uh, regulator that's on this motor driver to actually uh, power uh, power the encoder and to also power the BJT. Uh, I'm most likely gonna end up using the H bridge capability of it to start doing more advanced control uh, forward and driving the mower at a clockwise and counterclockwise uh, direction, and switching between different uh, speeds and states and whatnot and stuff. I think the end goal of this project is to build probably a balancing robot, uh, uh, and also utilizing this board. It has a gyroscope here, so utilize that and get that to build a self balancing robot, and that should cut down on costs and stuff. So it's pretty effective. Uh, yeah, the circuits right now needs a little bit of cleaning up and stuff. I think my main goal was just to try to to properly set it up and a also learn how to code this microcontroller. I've done a just an open loop control of this motor, actually just using embedded C and writing to registers. And for some more advanced control, I've used MATLAB to aid me with the code generation, uh, because it's it's easy to I've watched some videos explaining how to implement the embedded C control for the PID, but it takes a little bit more practice and a little bit more knowledge and stuff, kind of properly having it set up to where it's is is properly controlled. MATLAB kind of uh, really helps out and simplifies things for you, since it's uh, a diagram based sort of programming. I will show you an example of kind of what I'm been working on and stuff on MATLAB. But so the telematics that you were seeing there with the waveform, I'm using a yo ooh, Okay. So so yeah, guys, just be careful that you don't do get a power surge on oh yeah, let me cancel this. Yeah, man. Yeah. Yeah. Wapi? Wapi? Na jardin? Non, 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 non. Bato olingi bayozwa bango mo bayozwa mpo mwasi wana ye mo aya kozwa yango. Na otala so naza na tala nazosala makambo nazosala makambo. Ma lobaka ke olingi opesa makambo epa bato oza na besoin kaka nini. Yeah, tiro opesa ba raison ke oyo hiver ezoya. Hiver eyaka air nini? Air oyo hiver ezoya air oyo te. Okay. Sikoyo olingi makambo nyonso ebukama mpona nde ozoloba oyebisi nga 3 biloko ebukama. Sikoyo eloko nini eza important makasi mpona yo nyonso.